So, in the last lesson, we added a simple character into our game level. It's this little cube right here. In the last lesson, we added a piece of script onto the character so that if I go ahead and press the play scene button, my game will launch. Of course, my little blocks will fall. But if I press the up and down arrow keys on the keyboard and right and left arrow keys and the space bar, I can make my little character move forward and back, left and right, as well as jump. In order to do that, we added a little character into our scene, which I named Steve. And on Steve, I added a script file, which if I go ahead and click on that little script icon, it'll switch me over from the 3D workspace into the script workspace, where I can then go ahead and see all of the code that's on Steve. Now, this course is designed for absolute beginners to programming, so in this lesson and in the next lesson, I hope to demystify a lot of what's going on in this code, enough so that you have an idea of how to start working with it and following along with me as we work on this code and other pieces of code in this project to make the game that we want to make. So without further ado, there are 5 things we need to talk about to get us going and up to speed in the wild world of computer programming. First up is language syntax. The word syntax means the rules of a language. GDScript, and this is GDScript 2.0 as of Godot 4. There's a new version of this language. The first thing you should know is that this language is case sensitive. So if you type the word velocity, and that is a very important word as you're making your character move in your game level, it matters if you type velocity with a capital V or a lowercase v. Likewise, if you say is on floor, you must capitalize it exactly in the way that Godot or GDScript expects you to. The next thing is tabs or indentation. GDScript, like the language Python, expects you to indent or tab very precisely. You can see in the code editor right here, on the left side of many of these lines of code, you see a little tiny symbol. It looks right like that, and it means that there has been a tab typed right there. So if you do not tab in, if I delete this tab right here on that line of code, the code will no longer work. You can see it's complaining at me with lots of lines of red highlight. It does not like that. You must tab exactly as GDScript expects. So I'm going to go ahead and press tab, not spaces. It must be the tab key on your keyboard to make it work. Common characters. In GDScript, you're going to see lots of characters that you wouldn't normally write in everyday English, like colons. Colons come at the end of some lines. You're going to also see round brackets or parentheses. You're going to see periods or dots between different words, and those are important to have. And you're going to see symbols which are called operators, like the equal sign. You'll also probably see somewhere here or there symbols like plus, minus, times, and divide. Those are all going to be found in a programming language like GDScript. Last up, you're going to see lots of keywords used again and again in a language like GDScript. You're going to see words like function or func. You're going to see things like const, which means constant. You're going to see words like if, else, as well as not. And pay attention to the capitalization of all of those aforementioned words. Before we move on to our next point though, I'm going to have you actually follow along with me and create a new object in our 3D scene. So I'm going to jump back over into the 3D workspace here, and I'm going to select the root node of level 1, and I'm going to press plus to add a new type of node that I haven't mentioned before, and that is going to be found under node 3D, under visual instance 3D, under, if I can get this little prompt to hide itself, I'll click on something else, under geometry instance 3D. It is called Sprite 3D, and it's going to be under this little subcategory, and it's called Sprite 3D. It's probably easier just to search for it, Sprite. And there it is, Sprite 3D. We'll go ahead and double click to add one of these into our scene. A Sprite 3D is simply a flat image that you can add into your 3D scene, and it'll show up essentially as a plane or a flat surface, which you can rotate and position anywhere you want in your 3D world. So if I select that Sprite 3D and go over to the inspector, it has an empty texture slot right here. What I'm going to do is actually just use the Godot icon, which Godot actually gives us down here in our file system doc. It's called icon.svg. If I have my Sprite 3D node selected and I drag icon.svg into and let go of it right above that empty texture slot, I'll let go. You can see now it shows up right there as a resource that we've plugged into the texture property, but it's also now in our game level right there. And I can go ahead and move it up, and I'm going to move it forward on the Z axis so it's a little bit closer to my camera. If I go ahead and save this scene, Control S, and I go ahead and press play scene, you can see now that it is a flat surface in my game level that does not act as a physics object. It's just there visually, which is nice. The reason I'm adding this into the game level is because we're going to do a little bit of coding, and you can actually try some coding for yourself on this sprite object. I'm going to go ahead and rename it though. I'm going to call it, by double clicking on it, I'm going to call it icon, like that. Okay, I'm going to go ahead and select that node, and I'm going to press the add script button. And when we do that, we can leave everything as the default. It'll name this code file the same name as the node itself, so icon.gd, and I'll press create. When I do that, Godot now opens up that code file in the script workspace, and we can start typing code. The next big topic of this lesson is variables, data types, and constants. What are these? Well, if I go ahead and jump back over to Steve's code, so I'll just simply click on Steve's little script icon right here. You can see that at the top of Steve's code are a couple of variables. Actually, they're called constants, which hold data that Steve needs to know in order to move around. What are variables? Well, back when I was in grade 2, my grade 2 teacher in a math lesson taught me that there are some types of math questions where you actually get given the answer, but the question itself might be something like 3 plus triangle equals 7. And therefore, triangle equals what? You're given the answer, but you're expected to fill in one of the blanks, in this case, the value of triangle. Now, later on in later grades, like in middle school and high school, we got used to not using shapes like triangles. We got used to using letters like X and Y, and those values are called variables. A variable in computer programming is like a box that can contain a piece of data. And that's exactly what a variable is in computer programming, except the box is actually like a piece of memory that can hold data in your computer's RAM, or random access memory. In GDScript, in a code file, I'm going to actually now go back over to my icons script file by clicking on the little icon right here. You can add new variables into your code so that your code can remember things that it needs to remember for a little bit later on. An example of this might be if you're creating a game where you're collecting coins in the video game, kind of like we're going to do in this game project, you would need to create a variable to keep track and remember later on how many coins you've collected so far as you're playing the game. So at the top of my code, actually right below where it says extends sprite 3D, you can ignore that for now, I'm going to click and type the keyword var. Var creates a new variable. When you make a variable, you have to give it a name, and these names cannot contain spaces, and generally they should not start with numbers, and they should not contain special characters like $signs. So I'm going to name this variable coins, and I'm going to assign it a value by using the equal sign. I'm going to say 5 and press enter. There we go. It looks red right now, but the red disappears, and that means that GDScript is likely happy with that line of code. We've created a variable that holds a simple whole number called an integer. And that brings me to my next point, which is variables can hold different types of data. If I make a variable, and you can make as many as you want at the top of your code here, I'm going to make a variable called var name, and I'm going to assign it to, this time, some words. I'm going to say the name of this object is, well, it's a picture of the Godot icon with the little robot. So I'm going to type in robot. There we go. This variable, just like coins, holds a piece of data. However, this time the data is called a string. A string means words that you put in quotation marks. Now, some variables like coins work best if the numbers are whole numbers, which are called integers. However, you can make variables that hold numbers with decimal points as well. I can make a variable called, let's say, hearts. And you might be familiar with the idea that when you play some very famous video games, you can have hearts that represent your lives, and those hearts can be a whole heart or a half heart, and you might keep track of those numbers of hearts with a decimal point by saying equals, let's say, 3.5. That would work as well. This type of data is called a float. A float means a number that has a fractional value as a part of it as well, as opposed to an integer, which is only whole numbers. Oh, you know what? I realized that I've actually used a variable name that I'm not allowed to use. It's giving me an error here on line 4. It's complaining at me because the word name is actually already taken. I can't make a variable of my own called name because my node, which I have this script file on, already has a built-in variable in its code called name. So I might want to use a different variable name. I'm going to say player underscore name. And that should fix it. Okay, so sometimes there are words that you can't use, like if or else or func, that Godot already knows about. You have to come up with your own words for variable names. Okay, now one of the neat things about variables is that you can change them later on. Later on in your code, if you have a variable to keep track of how many coins you've collected, and that variable has the value 5 assigned into it, well, later on, if you touch another coin and collect that coin, you can change its value. When you want to access a variable later in your code, you don't have to say the keyword var all over again. You can just say the variable name, like coins, and make it equal to a new value, like 6. And that would be perfectly valid if I had put that line of code somewhere where it makes sense lower down in my code. And don't worry, after these next few lessons, this lesson and the next one, you'll understand where you'd have to put that line of code for it to actually work. But just know this is a valid line if it was somewhere else. Okay? If we go back to Steve's code though, you'll notice that there are no examples of the keyword var. If I go back and click on Steve's little script icon, you can see that there are variables declared up here at the top. However, they have the keyword const. So what is that all about? If I go back to my icons code, let's go ahead and create one of these. I'm going to say const, and I'm going to give this variable a name of speed, and I'm going to make it equal to 2. What is this all about? Well, a variable is a piece of data in your program that is meant to be changed later on. If I have a game where I collect coins, then I'm creating this variable at the very beginning of my game. And then later on, hopefully the player actually collects more coins. And that means that this variable's data, the number assigned into the coins variable, hopefully that number will change. And that is possible with a variable. However, there are times in your game programming where you want to create a variable and ensure that it will never ever change as the game is running. This is called a constant, and that's what the keyword const means. In GDScript, you typically name constants with all capital letters, and that's why you see that over in Steve's code. Whereas if you create just variables, as I did for my icon with coins, player name, and hearts, you don't have to use capital letters. Do you have to do this? Do you have to name constants with all uppercase letters? No, you don't, but it's what's called convention. It's what other programmers expect you to do. So to make sure that everyone uses the same standards, you probably should do that as well. Just a couple more things about variables before we move on. The first thing is, if you want to access the data inside of a variable, all you have to do in GDScript is use that variable's name. So if I want to make a new variable called x, I'm going to say var x equals. If I want x to equal coins, well, I can simply access the 5 that's in my coins variable by saying coins. And what this means is that my variable x will get the value of 5. If I want to make it one more than coins, in other words, I want x to be coins plus 1, I can do that. I can say coins plus 1. If I want to combine multiple variables together, let's say I want to make x equal to coins plus speed, even though speed is a constant, they're both integer types of data, 5 and 2. So I can say var x equals coins plus speed. Why would I ever do that? I don't know. This is an example, but you'll see things like this all over the place in GDScript. Okay. Lastly is that the type of a variable, the data type that you assign to a variable, like var coins is being assigned the value 5, which is an integer, is dynamic. And what does that mean? Well, coins right now has an integer value assigned to it, but later on, if I want to make coins be a different type of data, like a string, words with quotation marks, I can do that. I can say coins equals Fred. And when I do that, and if I type it correctly, coins equals Fred, that would be a valid line of code. Again, if I put this in a proper location, not at the very top of my code. We'll get to that a little bit later in this lesson. Okay, so I'll go ahead and delete that line of code. Next up are operators. Operators are symbols that perform a simple action. You can already see examples of two different operators on my screen right now, and they are the equal sign as well as the addition operator, which is plus. Symbols that do something in code are called operators. The equal sign is actually not called equals. The equal sign is called the assignment operator. And how the assignment operator works is the value on the right side of the equal sign gets stored or assigned into the variable that's on the left side of the equal sign. So you can see on the very top line of my variables on line 3, I'm assigning the value of 5 to the variable coins, and it's being put inside of that coins box, if you will, or more precisely, the location in memory where coins is being stored or pointing to, the value 5 is being put in that location. So the equal sign is called the assignment operator. We can use the plus sign for addition, which is called the addition operator. We could also use minus or times, which is the asterisk key, which is normally Shift 8 on most North American keyboards, I believe. There is divide, which is a /. So now you know how to use plus, minus, times, and divide, as well as the assignment operator. There are more operators. We'll get to them as we go, but you should know that term, operators. Next up are comments. Comments are little notes to yourself as a programmer that you include in your code, but they don't count as code and they don't mess up your otherwise valid code when you type them. When you type a comment in GDScript, that line needs to begin with a # or hashtag. When you type a # or hashtag, you can then type whatever you want after that symbol, and it's just a convenient little note for yourself to help you describe what's happening in that section of your code, especially if your code is many dozens or even hundreds of lines of code long. You can see that in this default code that we got on our icon, there are a few comments that describe the two sections of the code that we've been given. This section, called func ready, is called when the node enters the scene tree for the first time. What that means is this section of code is meant to only run once when the icon first loads into the game, essentially when the game level first starts. This section of code is called on every frame. Delta, this value right here, which is a variable, is the elapsed time since the previous frame. You don't need to know what that means right now, but essentially this section of code runs at 60 frames per second again and again and again. So any code that you put there will run very, very rapidly again and again and again. On Steve's code, if I jump back over to Steve's code right here, you can see that they've documented what's happening in this code using comments. So on this line 7, we have a descriptor right above it in a comment that says, get the gravity from the project settings to be synced with rigid body nodes. In other words, our game character has a variable called gravity, which we're not giving a number to just in the code. This code actually jumps into the project settings in Godot, where under physics and 3D physics, there is already a default gravity value. It's 9.8. And so we're not typing 9.8 here, or it wasn't typed for us here. It goes into the project settings so that your character actually falls with the same gravity that the physical block objects fall in our game level at the same speed of gravity. You can see comments throughout the code that was given to us for our character. If you read through it, add the gravity, handle jumping code, handling input from your keyboard to make your character move in the right direction. And that's pretty much it for the code that we have on Steve as it stands right now. It's a good habit to get into as a programmer to write your own comments to document what little sections of code do. Usually you put a comment right above a section of code, or if it's just one line that you want to comment, you can add a hashtag or a # at the end of the line, and then you can write your own description. This line of code on Steve happens to actually update velocity, pushing it downward on the screen. Okay, Back to our icons code though, and the last topic of this lesson is calling functions. A function in programming is a little section of code which you can consider a mini program within your larger program. A function is a small program that is meant to do one task. You can tell a function to run by calling that function. Where can you call a function? Well, you can call a function to run in either of these two sections that I mentioned that we have by default on our icons code. So either when we first add our character into our game level, which is when our game first starts, when we press play scene, or we can run a function 60 times per second in this section called function process delta. Now, don't be confused between functions that we are actually writing ourselves and the content of in our code file. There are actually functions all over the place already built for you into different parts of GDScript, including just global functions that you can call from anywhere. Here's the simplest one. In this section of our code called funcReady, I'm going to replace this line that says pass with a function call to print something onto the screen. There is a global function called print. And when you call a function, you write its name. You then have to write parentheses or round brackets. And in this case, the print function will print text or symbols into the output dock when you play your game. What do I want to actually print? Well, every programmer, when they learn a new language, always creates a new program called Hello World. So I'm going to type in quotation marks the text Hello World. When I do that, and if I save my code file, Control S, because this function is being called when the icon first loads into the game, when the game is running, when the game first starts, if I press the play scene button right now with my level 1 tab active, I'll go ahead and press play scene. You will see that my game runs, but that one line of code printed Hello World into my output dock, which is this tab right here. I can hide it and I can show it. There it is, Hello World. I'll go ahead and press stop. If I were to move that print line, so I'm going to select it and cut it, I'll press Control X on my keyboard. You have to actually go ahead and add the word pass back onto that line so Godot doesn't complain at you. Just trust me on that one. If I go ahead and paste that line, Control V right there. Again, make sure you are tabbed 1 in for both of these lines. That's important. If I go ahead and press play scene right now, I'll do a Control S to save first. I'll press play scene. My game will launch and you can see the game is running, but it's printing Hello World 60 times per second. If I go ahead and close my game, you can see if I scroll, it printed Hello World a whole lot, 60 times per second. We are calling this print function. We are giving it an argument. An argument, or sometimes called a parameter, is when you give that function some data that it needs to know how to do its job with. Like, what is it going to print onto the screen? You have to put that in the round brackets. Can you put other data in the round brackets of print? Yes, you can use variables of any type. If I want to print out coins 60 times per second, I could simply type coins right there. I could save, I could press play scene, and you can see it's printing 60 times per second on my screen. Are there any more exciting and relevant functions that we can use and call that will actually make our little sprite in our 3D world actually do something? You bet. If I go back into my script workspace onto my icons script, 60 times per second, I'm going to call a function called rotate _y. Now you'll notice that as you're typing code, there will be a little helper pop up that is auto predicting for you what you want to type. And you can use the up and down arrow keys on your keyboard to highlight and select the one that you want. If you don't want to keep typing it for yourself, you can simply use the down arrow key, select rotate _y, and press enter. Rotate y is a function. It's actually called a method. I'm not going to get into the difference between functions and methods. Those two words are synonymous as far as you need to know in this lesson at this point in your programming journey. We are calling a function or a method here called rotate y, and it needs to know the angle at which we want to rotate our sprite 3D called icon 60 times per second. Now, this rotate y function needs an argument or a parameter. It needs an angle. Now, you might think of angles as being in degrees, as in 360 degrees makes a circle. However, this function requires a value in radians. Now, I'm going to type, just to see what happens, 0.1 radians. If I go ahead and save, and then I select my level 1 tab, and I press play scene, you should see that your little sprite 3D is spinning on the y-axis. Y runs up and down as your game runs, again, 60 times per second. If you change the argument value from 0.1 to 0.05, well, it'll rotate slower. So if I press Control S to save, make sure level 1 is my active tab, and I press play scene, it runs or rotates at half the rate. Can I use a variable to determine the speed of rotate y instead of typing in 0.05 myself? Yes, I can use that constant speed. So I'm going to type in, matching my capitalization here, speed, all in uppercase. And if I press Control S to save, and I press play scene, well, my little sprite 3D rotates very, very fast. What if I want to use degrees instead of radians? Well, there is a function for that. There is a little function, a little program that does one little job for us. It converts degrees into radians. So if I want to rotate 60 times per second this little sprite in my game 2 degrees and not 2 radians 60 times per second, I can call a little function right inside of these parentheses called deg, or degrees, _2, and you'll see it prompted for me right here. So I'll just press enter on my keyboard. This function is called degrees to radians, or deg to rad. And what you can do here is type in a degree value. I'm going to type in speed, which is 2, and it'll convert that value in degrees to radians and put that value right here. And then we're giving that new value, which is 2 degrees converted into radians, to the rotate y function as its argument or parameter, so that it gets the radians value, but we were able to type in a number that we're more comfortable with, likely in degrees and not radians. So there you go. We're calling a function and then getting a value back from that called a return value. And then we're giving that value to rotate y. There we go. I'll press Control S to save. I'll press play scene. And now our little character rotates 2 degrees 60 times per second. There we have it. And I think it's at this point that I've thrown a lot at you in this lesson. In this lesson, we've talked about language syntax. We've talked about variables, data types, as well as constants. We've talked about operators, comments, and calling functions or methods. But I think that'll be it for this lesson. Thank you so much for watching, and I'll see you in the next one. Bye-bye.